Hello, welcome Hornets, and thank you for joining me today. Um, we're going to be working on graphing of a tangent, and my goal is to just try to help you to understand how to graph a tangent. So the first thing to keep in mind is that when you graph a tangent, tangents look like cubics, but they have infinite discontinuities at each end. So whereas a cubic just goes on infinitely in both directions, a tangent, is going to stay in between two asymptotes. Now, the vertical asymptotes, as we have seen them, are when the tangent is undefined. And tangent is undefined at negative pi over 2 and pi over 2. And then we're going to have 3 pi over 2. Now I can go backward as well, in which case I would have negative 3 pi over 2. And here we have negative pi. This is positive pi. Now, we're going to start by putting our asymptotes on the graph at the two locations where tangent is undefined. Now, this is your standard tangent graph. Okay. And we currently know several things about tangent. First of all, tangent is 0 at pi, or at 0 pi. We also know that tangent is going to be located at a 1 and a negative 1 at pi over 4, or halfway through. So right here we have a point here, and we have a point here. We know that our curve is concave up and approaching the asymptote on that side. On the other side, concave down and approaching the other asymptote. So our last step is to plot our points. We have negative pi over 4, negative 1, pi over 4, positive 1, and 0 pi is 0. We're now going to do 2 more periods. After all, just like all of the other trig functions, like sine and cosine, these are cyclic. They are periodic, which means they repeat themselves over and over and over again. And I'm just going to make sure that I label my asymptotes all the way across. I didn't do that at the beginning, but I am going to do that now. X equals negative 3 pi over 2. X equals negative pi over 2. X equals a positive pi over 2. And X equals 3 pi over 2. We're now going to plot our 0 at 2 pi, our 0 at negative pi. We know that if this is pi over 2, then this has to be negative 3 pi over 4. And right here we go up by 2 more, and this is negative 5 pi over 4. Just like this was negative pi over 4, positive pi over 4, this will then be a positive 3 pi over 4, and a positive 5 pi over 4. And so they go by 2s. 5, 3, 1, 1, 3, 5. And we know that we have a positive 1 at the fourths to the right, and we have a negative 1 at the fourths to the left of that 0. So let's go ahead and just put negative 1, positive 1. And now we're going to draw our curve. Along the asymptote, concave down, concave up, going along the asymptote, going up, repeat, and repeat. Now we can always put more points in if we wanted. For example, we know we've got root 3 root 3 and root 3 over 2 at the pi over 3's and the pi over 6's. But that isn't absolutely important. We just need to have enough to show us what's happening on the graph. Please remember to go back and plot your points on the graph. If we were just asking questions about it, we could write them separately. We wouldn't have to write the points. We could just give locations, values. But here we're actively graphing, so we want to make sure that we put them in. So we have 0 at 2 pi 0 again, 5 pi over 4, so 1, and positive 3 pi over 4 is a negative 1. This is the graph of a tangent. And that's what a tangent looks like. Notice how we use our 1 and negative 1, 1 and negative 1, 1 and negative 1, and we can keep finding as many periods as we like. That's the graph of a tangent. What you're currently looking at, let's just make sure we label it, is y equals the tangent of theta. Now there is no stretch. Okay, we're not multiplying by anything in front of theta that will cause it to shrink or stretch or squeeze and stretch. There is no vertical shift. There's no change in our period. Okay, let's go ahead and take a look at a standard cotangent. And let's just look at y equals the cotan of theta. We start with our graph. And just like our tangent, we have asymptotes. Now it's hard to see this one. It is on the 0. I'm going to put it right next to it just so that we can see it. But it is overlapping, and it is on the y equivalent vertical axis. I'm going to make sure I label this as theta equals, well, yeah, let's do it x. Let's call it an x. It is the x-axis after all, since we are drawing on the graph, and it is in radians. So x is equal to 0 pi. Now, cotangent, we also know, is undefined at pi. So I'm going to locate pi on this graph, both sides, and negative pi, which means halfway in between is a pi over 2 and a negative pi over 2. Let's put in our vertical asymptotes. So you'll notice I'm currently looking at 2 periods of our cotangent. And I'm going to go ahead and I'm going to label them. I got to label them at some point anyway. Might as well get that done immediately. So we have theta x equals negative pi. We have our x equals 0 right here, which I put up above. And then we have x equals a positive pi. Now, just as we did before with the tangent, we're going to make sure that we put our fourths. We've got our fourths in. And we know that in the first quadrant, our tangent is positive. And so between 0 and pi over 2, we're going to have a positive 1. It's going to put it right here. And then at 3 pi over 4, we know cotangent has a negative 1. And then we have our 0 at pi over 2. So our curve is going to be concave up, going toward the left this time, and concave down toward the right. And we're going to plot our points. We have pi over 4, positive 1. Pi over 2 is 0, according to our unit circle. and 3 pi over 4 is a negative 1. Then we're going to repeat the process. 1 or 0, negative 1 at the negative pi over 4, and a positive 1 at the negative 3 pi over 4. Once again, we have concave down and decreasing, then concave up and increasing. We label our points, negative 3 pi over 4, comma 1, and negative pi over 4, comma negative 1. And this is graphing cotangent. And you'll now notice I currently have 2 periods of a cotangent, and I could do more by simply going to 2 pi and locating 3 pi over 2, and then our 5 pi over 4 and 7 pi over 4. So we can keep going, and this just continues. So you could do 3 periods like we did with our tangent in the last graph, or we could do more. All right, let's go ahead and start taking a look at what happens when we have different components. So let's take a look at a y equals, and we're going to put a whole bunch of it together. So let's do 3 tangent of 2 theta plus 1. Now you notice there is no phase shift, and without a phase shift, we're still dealing with our pi over 2 and our negative pi over 2, followed by pi, 3 pi over 2, negative pi, negative 3 pi over 2. Let's go ahead and just label these on the graph so that we know where we're at. Pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. We're now going to put in our asymptotes. The asymptotes are at pi over 2 and negative pi over 2. We're going to skip through one length of pi, 180 degrees, and find our next asymptote. Then skip another 180 degrees or length of pi, and we get our third. I guess this is our fourth asymptote. And you'll notice that we now have the asymptotes that we can identify. X equals negative 3 pi over 2, x equals negative pi over 2, x equals pi over 2, and x equals 3 pi over 2. So you'll notice I started with the asymptotes. I'm now going to go ahead and I'm going to locate my vertical shift. Let's go ahead and use purple this time. It's not easy to see, but that's at a positive 1. This center line is where our zeros are located. This is y equals 1. And now we're going to have to plot some points. So the points that I'm going to plot are 0 pi, and you'll notice this is without the shift, so the shift moves it up 1. Then we're looking at our pi over 4, negative pi over 4, and the amplitude is going to be important here. So you'll notice that the amplitude, or the dilation, however you want to call it, is a 3. It's not really an amplitude. It's not really a dilation. It is a speed at which it's moving up. Okay, and I had a change in my period. So I tab the change in period, and that means that each of these is going to have to change, Mr. Lamb. After all, we have 2 pi divided by b. So I'm starting off with all of the standard stuff. I'm going to have to change it now based upon that b value. Now the graph stays the same. All that's changing is the location of the asymptotes. Now, I could have done this at the beginning. I just forgot. But anytime you're doing a graph, you always have the opportunity of changing your information as you see fit. So don't let yourself get bent out of shape. You just go through and you say, okay, well, what is our period? 2 pi divided by 2, which means that our period is now a length of 1. So instead of this being going off to 2 pi, I'm looking at pi over 2 here. This is going to then be pi over 4. This will then be 3 pi over 4. This will then be negative pi over 4, negative pi over 2, negative 3 pi over 4. So you'll notice I took that pi over 2 and I multiplied by 1/2 and it became pi over 4. I took the pi and I multiplied it by 1/2 and it's now pi over 2. The pi that was right here is now negative pi over 2. And the negative pi over 2 multiplied by 1/2 is negative pi over 4. So that's all that's happened. So it's instead of negative 3 pi over 2, it's negative 3 pi over 4. Instead of negative pi over 2, it's negative pi over 4. Positive pi over 4. And positive 3 pi over 4. Well, what's that going to change for our intermediate values? This is no longer pi over 4, it's half of pi over 4, and therefore is pi over 8. This would then be negative pi over 8, and as I go along, I'm now going to have 3 pi over 8, and negative 5 pi over 8. You'll notice it's the same values, just multiplied by 1/2. 3 pi over 8, 5 pi over 8. Okay, we're now ready to draw our graph. Now, keep in mind that we have times 3, which means that when I get this 1 from pi over 8, notice 2 times pi over 8 is pi over 4. The tangent of pi over 4 is 1, and I'm multiplying that 1 by 3. That 3 then jumps by an additional 1, and so I'm going up 3 from this to locate 4. Notice that just stretched my graph. 1, 2, 3. Stretched my graph. Concave up to the right, heading toward the asymptote. Concave down to the left. And now we repeat the process. Concave up, then increasing. Concave down and decreasing. Center line is at 0. Moving up 3. Going down 3. Concave up and increasing toward the asymptote. concave down and decreasing toward the asymptote. We're now going to plot our points. Negative 5 pi over 8, comma, and you'll notice I'm at negative 2 now. Let's get some light into this situation as my lights just went off in the building. It is, after all, a holiday for everybody else. Negative 3 pi over 8, and I'm now up at 4. Then I do negative pi over 8, negative 2. Well, don't forget, negative pi over 2, Mr. Lamb. This is at 1, 0 pi 1, pi over 8, 4. I'm making a little bit of a mess here. 3 pi over 8 is at negative 2. 5 pi over 8 is at a positive 4. And there is my graph. I have 3 periods. I have the asymptotes located. I've got the center line located. I've got the change in the period identified. I've got the locations of the 3 points that are creating the curve. I'm done. Let's do a cotangent, shall we? This time, I'm going to try very hard and do the period from the get-go, okay? Here we go. Let's do y equals negative 2 cotangent of 3 theta, and let's do a plus 4. Okay, once again, no phase shift. Phase shift requires us to locate the values based upon equivalent values for theta. Now, you probably saw me do that in one of the other videos when I was working on sine and cosine. If you didn't, you may want to consider it. Alrighty, I'm going to go ahead and I'm going to locate my center line. So we're looking at the center line is sitting there at, let's do purple again, sitting there at plus 4. So I've got 1, 2, 3, and 4. Okay. Now, because the dilation is up 2, down 2, I'm just going to make sure that I have 2 additional ones going up, and I have the 2 going down. Center line is very easy to locate. It has nothing to do with any of the other values. All of the other values, frankly, do benefit from having it found prior to beginning. So I would recommend you find your center line as the first thing you do. We're now going to find our period, 2 pi divided by 3. So let's just make sure we put 2 pi divided by 3, and that will give me half is pi divided by 3. So here's my half, pi divided by 3. Here is negative pi divided by 3. Here is 0 pi, and there is no phase shift. So I've got 2 pi over 3 on this side. That's giving me 1 full rotation, and we know that there are 2 asymptotes within 1 full rotation. And we have over on this side negative 2 pi over 3. And all of these are locations of asymptotes. So let's just go ahead and put in our asymptote. Once again, I'm doing it right beside so that you can see it. Normally it would overlap, but it tends to be difficult to see. I'm just putting it right along the side just so that we can see it clearly. Going up, going down, going up, going down, up, going down. Now you'll notice I've got, 1, 2, 3, 4 different periods being shown here. Remember, you have to think about it because sometimes they'll ask for more than one period. They very rarely ask you for just one. Now I'm going to identify all of these asymptotes. So x equals negative 2 pi over 3, negative pi over 3, 0 pi, pi over 3, 2 pi over 3. Alrighty, we're now going to go ahead and start plotting some points. In order to do that, we've got to take the middle. Half of pi over 3, negative pi over 3 is negative pi over 6. Pi over 6. 2 pi over 6 is there, so we're looking at 3 pi over 6 gives me pi. 1 pi over 6, 2 pi over 6, negative 3 pi over 6 is negative pi over 2, excuse me. Negative pi over 2. And I'm now ready to begin. I know, for example, the center, the 0 is sitting right on the center line. I got 4 points already done. But we need to go halfway in between. That's going to give me a pi over 12. That's 2 pi over 12, which means I'm looking at 3 pi over 12, which is pi over 4. On the opposite side is negative pi over 4. Then you have 4 pi over 12, giving me 5 pi over 12. This is 6 pi over 12 to give me negative 7 pi over 12. Working on the other side, if this is 1 pi over 12, right here, I have 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12. 6 pi over 12, 7 pi over 12. I'm now ready to plot those points. We know we go up by 2. Once again, 2 plus the 4 makes 6. So right here, and let's just make sure that I do this correctly. So let's go. Pi over 12 gives me the cotangent of pi over 4, which will be a 1, times negative 2 is negative 2, plus 4 makes 2. So at pi over 12, I'm at 2. Then I put in a pi over 4, gives me 3 pi over 12, 3 pi over 4, excuse me, and that gives me a negative 1. Negative 1 times negative 2 is positive 2, and positive 2 plus 4 makes 6. I'm now ready to do my concave down, approach the asymptote, concave up, approach the asymptote. So that means 5 pi over 12 is going to be in the same location at positive 2. 7 pi over 12 is at 6. Negative pi over 12 is going to be at 6. Negative pi over 4 is going to be at 2. 5 pi over 12 negative is going to be at 6. And negative 7 pi over 12 is going to be at 2. Concave down and approach the asymptote. Concave up and approach the asymptote. Concave down and approach the asymptote. Concave up and approach the asymptote. Concave down and approach the asymptote. Concave up and approach the asymptote. We now plot our points. So I have pi over 12, 2. Pi over 6, 4. I have pi over 4, 6, 5 pi over 4, 5 pi over 12, 2, pi over 2, 4, 7 pi over 12, 6. We now have 2 periods. We continue. Let's do our negative pi over 4, 2, negative pi over 6, 4, negative pi over 12, 6, negative 5 pi over 12, 6, negative pi over 2, 4, and negative 7 pi over 12, back to 2. And this is now my graph of negative 2 cotangent 3 theta plus 4. That's graphing a cotangent. Alrighty, let's go ahead and do the hard ones. This time, let's take a look at a tangent, and keep in mind the tangent and cotangent are going to follow the same basic pattern of steps. And I'm going to be looking at y equals 2 tangent 3 theta minus pi over 2. Let's do pi over 6 plus 1. Alrighty. Step 1, I'm going to draw my graph, the general graph, just like I've done. I'm going to locate the center line. The center line is going to be at 1, And I want to go 2 up, 1, 2, and 2 down, 1, 2. So I've got negative 1 here, 0 here, 1, 2, 3. The center line goes across at 1. And I'm now going to try to match points. So in order to do that, I'm going to start off with where is the location of 0 pi? It's the center of all tangents. So 0 pi has to equal 3 parentheses theta minus pi over 6. Once again, the inside piece has to equal that 0 pi. Dividing by 3 is still 0, and adding pi over 6. So the first value that I'm working with is pi over 6 equals theta. I'm now going to locate what is the next value, pi over 2. Now this is the asymptote. So I have it equal to 3 theta minus pi over 6. Divide gives me pi over 6. And I'm then going to add another pi over 6. 2 pi over 6 is pi over 3. And therefore, pi over 3 is my next theta. So how far did I go? Well, I went and I started at pi over 6, and then I went another pi over 6 over. So we're going to start by locating pi over 6. This is where the center is. We're going to move over a pi over 6. That's where the asymptote is. This is at pi over 3. Now the other asymptote has to be equidistant, which means that it's now at 0 pi. Now we could check that by taking pi over 2, setting it negative pi over 2, and equaling 3 times theta minus pi over 6. And we will find out that it's at 0. I'm going to locate my first asymptote. Theta equals pi over 3. I'm going to locate my second asymptote. Once again, it's moving along. It's in the same place as that vertical axis. So I'm just kind of putting it along the side so we can see it clearly. Theta equals 0 pi. Now, if I continue with this, I know that the next value has to be 1 pi over 6 over, and that's going to give me 3 pi over 6, and therefore pi over 2. And then the next one would be 4 pi over 6, which is 2 pi over 3. Let's just make sure. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Therefore, I can go over to a negative pi over 6, and then negative pi over 3. We're currently looking at 3 periods of our tangent. I'm just drawing my vertical. And then these should have been x's, not thetas, Mr. Lamb. I'm just going to go ahead and I'm going to correct that right now. These are now x's. These are lengths. All right. Now we're ready to graph. We know we started at 0 for each of them. And we need to go halfway between. So that's going to be at pi over 12. And if I put in the pi over 12 minus pi over 6 is going to be a pi over 12 times 3 is pi over 4. Tangent of pi over 4 is 1. 1 times 2 makes 2, and then 2 plus 1 makes 3. Working backward, so let's just make sure I plot that point. We have, negative pi over 12, comma 3. And we know that we'll have pi over 12, 2 pi over 12, 3 pi over 12 is pi over 4. And that is 2 down. Therefore, negative 1. Concave down, approaching my asymptote. Concave up, approaching my asymptote. And I'm now ready to do pi over 12 on this side, pi over 4 on that side. Concave down, approaching the asymptote. Continuing, concave up, approaching the asymptote. Plot my points. Pi over 6 is at 1, just like negative pi over 6 was at 1. This was at negative pi over 12. And it's at negative 1. And this was pi over 4 at 3. And then I would continue. So if I have 1 pi over 12, that's a positive, excuse me, positive pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, this one has to be 5 pi over 12. So 5 pi over 12 is going to be at negative 1. 6 pi over 12, 7 pi over 12. That's going to be right here. So 7 pi over 12, comma 3. Concave up, going through the points and approaching the asymptote. Concave down and approaching the asymptote. Close enough. The only thing I haven't done is identified the very last asymptote, which I will now do as x equals negative pi over 3. This is now my graph of y equals 2 tangent 3 parenthesis theta minus pi over 6 the quantity plus 1. That's how we graph sine or tangent and cotangent, and I hope this has helped. If you liked what I've done, please remember to click like and let me know so that I get some feedback. And if you have some suggestions or some comments, please feel free to make them. I will continue with the next video on secants and cosecants, and we will continue in the next video. Thank you very much, Hornets. Take care, be well, and be safe. Cheers. Thank you. Bye-bye.